The first circle theorem is the angle at the center theorem. The angle at the center of a circle is always twice the angle at the circumference when they stand on the same arc. So if an inscribed angle is 30 degrees, the corresponding central angle will be 60 degrees. The second circle theorem is the angles in the same segment theorem. Any angle drawn from the same arc in a circle are always equal, no matter where you place them. If they stand on the same arc, their angles match. Take a look at this example. As you can see, one of the angles is 30 degrees. If you look closely, you can see both pairs of lines are on the same segment. Given this, we know that the other angle is also 30 degrees. The third circle theorem is the angle in a semicircle theorem. If you draw a triangle inside a circle where one side is the diameter, the angle opposite that side is always 90 degrees, no exceptions. This works because the triangle is essentially half of a full 180-degree angle. The fourth circle theorem is the cyclic quadrilateral theorem. A quadrilateral where all four corners touch the circle is called a cyclic quadrilateral. Here's the magic though. The opposite angles always add up to 180 degrees. Try it. Draw one and check with a protractor. It works every single time. The fifth circle theorem is the tangent and radius theorem. If a straight line just touches a circle at one point, it's called a tangent. And guess what? The radius of the circle at that point is always perpendicular to the tangent. It's a common principle used in engineering and physics. The sixth circle theorem is the alternate segment theorem. For any circle, the angle formed between the tangent and the chord through the point of contact of the tangent is equal to the angle formed by the chord and the alternate segment. Now this one's a bit complicated, but I think if you look at the diagram, you'll understand how it works. The seventh and final circle theorem is the chord of a circle. The perpendicular from the center of a circle to a chord bisects the chord. This means it splits it into two equal parts.